This is the Chapter 8 test review. For number 1, we're trying to factor these expressions completely. Remember, for these quadratics here, we're looking for two numbers that multiply to 32. And those same two numbers have a sum of 12. With the 32 example, it's not too bad. We got 1, 32, 2 and 16, 4 and 8. So when I find those two numbers here, they're both positive. So we'll be writing plus 4 and plus 8. Our variable here is m, so it'll be m times m. If it were negative 4 times 8, then it would be m minus 4 times m plus 8. In number 2, we have two numbers that multiply to 80, and their sum is negative 18. The only way I can have two numbers that multiply to a positive number, and their sum is going to be negative, is if both the numbers are negative. So, in this one here, it's going to be negative 10 and negative 8. So I'm going to write this like r minus 8 and r minus 10. The order doesn't matter. I could have written this like r minus 10 and then times r minus 8. But what we just did was factor. When we're looking at completing the square, unlike the examples where we factor and where to solve the quadratic equation and the examples where we need to do the quadratic formula, we want to move the constants, in this case the negative 10, to the other side of the equation so that we can have just the variables isolated. So I'm going to add 10 to both sides. V squared minus 10v is equal to a positive 7. We're going to take that number in front of the v here, or like the linear term. If you think about it in terms of the ax squared plus bx plus c for our quadratic equations, we're going to take b, in this case negative 10, and divide it by 2 to get negative 5. We're then going to square negative 5 to get 25. And we add 25 on both sides of our equation. So now I have v squared minus 10v plus 25 is equal to 32. The whole point of completing the square is being able to write this in the form of some binomial squared, like two terms squared. In this case, if it's v squared minus 10v plus 25, this is v minus 5 squared, and it's equal to 32. Now to undo the fact that this is squared here, I need to take the square root of both sides. One thing too I forgot to mention a second ago, that number that we're going to be working with is going to be b divided by 2 for what should be inside the parentheses here. When I take the square root of both sides of the equation, I get v minus 5 is equal to, and then we have to remember that the square root can be positive or negative. So plus or minus the square root of 32. The square root of 32 I can simplify as the square root of 16 times the square root of 2, or 4 square root 2. So I have v minus 5 is equal to plus or minus 4 square root 2. To solve for v, I need to add 5 on both sides of the equation. This is 5 plus or minus 4 square root 2. And again, these are two solutions. 5 plus 4 square root 2, and 5 minus 4 square root 2. For number 4, it's asking us to solve the equation with the quadratic formula. I'm going to have this written down. You don't have to memorize this. Negative v plus or minus b squared minus 4ac all over 2a. Again, just like the example I put above, the quadratic formula is going to work when we set this equal to 0. So I need to add 7r on both sides. So I get 3r squared plus 7r minus 6 equals 0. So this looks like, a is 3, b is 7, c is negative 6. So it's negative 7 plus or minus the square root of 7 squared minus, 4 times 3 times negative 6. All of this is being divided by 2 times 3. So this is 49. 4 times 3 is 12. If it was 12 times 5, it would be 60. If it was 12 times 6, that's when we're 12, that would be 72. So 49 plus 72 divided by 6, or negative 7. This is going to be the square root of 121 over 6. We get negative 7 plus or minus 11 over 6. Again, this is showing me two solutions. And I should rewrite this like negative 7 minus 11 over 6 and negative 7 plus 11 over 6. Minus 11 would be negative 18 over 6 to get negative 3. And the other one would be 4 over 6 to get 2/3. So my solutions are r equals negative 3 and r equals 2/3. When we talk about the discriminant here, inside the quadratic formula, or inside the radicand, what's inside the radical in the quadratic formula, b squared minus 4ac. If this number is positive, we get 2 real solutions. If it's 0, we get 1 real solution. And if it's negative, we get no real solutions. Technically, they'd be imaginary. Just like before, whenever we're working on these, it has to be with the quadratic equation set equal to 0. So I need to add 4 on both sides. I get 6p squared minus 4p. I'm going to put plus 0. You don't have to put plus 0, but it'll help me know that a is 6. Here, sorry, let me zoom in. A equals 6. B equals negative 4, and C equals 0. So if I have negative 4 squared, B squared, minus 4 times 6 times 0, I get 16 minus 0, or 16. So it's got 2 real solutions. This quadratic equation would have 2 real solutions. Graphically, this would look like the graph of the quadratic equation crossing the x-axis twice. In number 6, I'm going to add 3 on both sides of the equation. A equals 8, B equals 2, C equals 1. I've got 2 squared minus 4 times 8 times 1, or 4 minus 32. To get a negative 28. So there's no real solutions. They would be complex or imaginary solutions. We'd have to take the square root of a negative number. And this last one here, add 8. Add 9 on both sides. So I've got negative 8 squared minus 4 times 8 times 10, or 64 minus 320. If it was, this would be negative 256. So again, no real solutions. If this was the discriminant was equal to 0, then there'd be 1 real solution. So in the next 2 examples, we're going to be trying to solve these, and we're going to end up, like, our work is going to end up looking like a quadratic equation, even though these aren't written in the form like ax squared plus bx plus c. So let me just grab two different colors. We'll do green and red. I got x plus 2 as a factor below. X plus 5. When I'm looking at these examples and I'm trying to work on this equation, I can multiply both sides of the equation by x plus 2 times x plus 5. So if I have 2 over, I'm just going to 5 over when I multiply both sides by x plus 2 times x plus 5, it's going to take me a minute to write, but this looks like, oh, sorry, let me do on this side too. X plus 2 times x plus 5. It's going to look like x plus 2 times x plus 5. I'm going to copy this. So it's this times 2 over x plus 2 plus the same thing we're multiplying here times 5 over x plus 5. And I'm just going to try to color coordinate this part. Oh. Let me go back. So I'm multiplying both sides of the equation by x plus 2 times x plus 5. What I'm trying to show here is that in the denominator, if I have the x plus 2 and I'm multiplying by x plus 2, then these are going to cancel. I'm left over with x plus 5 times 2. And then the same thing's happening here. X plus 2 times x plus 5 times 5 over x plus 5. X plus 5 is going to cancel here. And this is still equal to, which I'm going to lasso and then copy. So together this looks like 2 times x plus 5 plus 5 times x plus 2 equals 4 times, and if I distribute here, this is going to be x squared. I'll put it on the side here. X squared plus 5x plus 2x plus 10, or x squared plus 7x plus 10. Now I'm going to distribute to each part, so I get 2x plus 10 plus 5x plus 10 equals 4x squared plus 28x plus 40. Instead of subtracting 2x and then subtracting 5x, I would want to group the like terms together to make this 7x plus 20 equals 4x squared plus 28x plus 40, and then subtract 7x on both sides. And then subtract 20 on both sides. Now this is set equal to 0, and at this point, it's not obvious to me how this would factor. I would probably do the quadratic formula. So I'd say this is A equals 4, B equals 21, C equals 20. This is going to be negative 21 plus or minus the square root of 21 squared minus 4 times 20. All of this is divided by 2 times 4. I don't remember what 21 squared was off the top of my head. I think it was 441. Let me see. Okay, so negative 21 plus or minus the square root of 441. And then 4 times 20 taking away 320, and we're dividing by 8. So 441 minus 320, another 121. So negative 21 plus or minus the square root of 121 divided by 8, or negative 21 plus or minus the square root of 121 was 11 divided by 8. Again, two solutions we're looking at here. Negative 21 plus 11 over 8 and negative 21 minus 11 over 8. Negative 21 plus 11 over 8 is going to be 10 over 8, and this would be negative 32 over 8 to get negative 4. So my two answers are x equals negative 4 and x equals 5 over 4, if I were to simplify 10/8. So that was one setup where you're going to be given this rational expression, which looks very complicated, but I'm multiplying by what would kind of end up being like that least common denominator. Here, imagining if I was trying to get rid of the fractions. The other scenario where you're going to have to end up with a quadratic is if you have this radical here. I'm going to square both sides of the equation. Negative 15 plus 8v inside the square root is going to be undone by squaring this, so I'm left over with what's inside the radical, that radicand. Negative 15 plus 8v is equal to v squared. Again, we need to make sure that we're setting these equal to 0. My brain has an easier time working with positive v squared, so I would probably add 15 on both sides and then subtract 8v, which I understand visually looks like it should be v squared minus, or plus 15 minus 8v. I'm just going to write these in the order flipped. So it's in standard form. Now at this point, there's nothing that says you have to solve these with the quadratic formula or completing the square. In that example we were looking at a second ago with factoring, we could try to find two numbers that multiply to 15, and those same two numbers combine to negative 8. If they combine to a negative number, then I know it's like v minus for both these, the two negative numbers. And 5 times 3 is 15. Negative 5 times negative 3 is positive 15. And negative 5 plus negative 3 is going to be negative 8. So if you were to solve this by factoring, that's fine. Just remember that we have to look at the two scenarios where one factor is equal to 0 and the other factor is equal to 0. It would be wrong to say that negative 5 is our answer. The right way of doing this would be setting v minus 5 equal to 0 and then adding 5 on both sides. The same thing with v minus 3. Set that equal to 0, add 3 on both sides to get v equals 3. And that's the gist of what's going to be on the test for Chapter 8. I remember I made a practice online. That should be there as well. Email me if you have any questions. But yeah, don't forget the setup to these. I'm going to provide you with the quadratic equation again, the negative b plus or minus the square root of b squared minus 4ac over 2a. I'm expecting you guys to remember what happens at the different values for the discriminant. If you have any questions, feel free to email me, and